In this video, we're going to look at how to approach a specific type of question called database questions. Now, in the O-level exam for pure chemistry, in paper 2, there are two sections, section A and section B. The first question in section B is designated to be a database question. Now, what is a database question? A database question contains a passage of several paragraphs that describes content or concepts that are not taught in the syllabus. Right, and students are required to use the content, the concepts that are being described to interpret, evaluate, and to solve the questions that follow. It's usually a 10 to 12 mark question. Now, what scares students about database questions is because the concepts have not been taught in syllabus, so they are usually unfamiliar. And when you see things that are unfamiliar, for example, the little diagram on the bottom right corner, we tend to get scared, we tend to get intimidated. So in a nutshell, the way to approach database questions, firstly, is not to be scared of it and not to be intimidated by it. And secondly, is to look for things that you can identify with. I mean, certain parts would resonate with what you have learned in the syllabus. And back to the picture that I was talking about, you can identify features that share certain commonalities with human beings. For example, it has eyes, it has a tongue, so they shouldn't really scare you. Now, there are three tips on approaching a database question. The first of which is that not all sentences are equal. So in the passage, usually quite a long one, if you choose to focus on every sentence, you get overwhelmed by the information and you don't know what to focus on. Alright, so take note that not all sentences are equally important, and you are expected to be able to tell which sentences are more important and to highlight those sentences for future reference. Okay, so if you see any sentences that describe definitions, relations, examples, you are expected to underline or highlight those sentences. Secondly, in a database question, very often you'll be given tables and graphs. Okay, so you are expected to use the values given in the table or the values given in the graphs to answer your questions. Okay, so whenever there is a describing, compare, contrast questions, do remember to quote the data from the tables and the graphs in your answers. And the next thing is that even though the passage contains information that we have not learned in syllabus, some of the questions are still related to what you have learned in the syllabus. Alright, so what you can do is to try to identify in this particular passage which chapter is it most closely related to. Okay, and what concepts did we learn in that particular chapter that will help you to focus on what is needed to answer the questions. Okay, the bottom line is this: bear in mind that Cambridge is not allowed to test you on things that are outside the syllabus unless further information is given. So there shouldn't be a case where you're expected to know things that you are not already taught. So let us try to apply the three tips that we have already learned into two examples of a database question. So the first database question is the 2020 O-level database question. So right now I'm going to go through the passage and we're going to try to underline the key concepts or the key content. Okay, so when you approach a database question, first thing is that you shouldn't be reading the passage word for word. Okay, so the very first time you are reading the passage is to skim through it, read very quickly through it, to roughly get an idea of what each paragraph is talking about. And as you are skimming through it, you're supposed to highlight or underline the important points as well. Alright, so this is what I'm going to illustrate. If we look at the first paragraph, it's talking about de-icers. So the first paragraph is giving an introduction to the de-icers, and usually introduction, they do not contain any important information. Okay, in the second paragraph, however, the question tells you that the most commonly used de-icer is sodium chloride because it's very cheap. Okay, and then another de-icer that's being used is calcium chloride, which is used in smaller areas. So it's a hint to you that it's not as cheap. Okay, in the next paragraph, in the past 2 years, Cambridge have been very kind to give headers for each paragraph. So the headers tell you roughly what each paragraph is about. So if we look at the header, it's telling you the next paragraph is describing on the effect of the mass of the de-icer use. Okay, so whether by increasing the mass, will it make it more effective? Alright, so when we quickly look through the next paragraph, it seems to be telling you that there's a scientist that conducted an experiment, and in the experiment she added different masses of sodium chloride to 100 centimeter cube of water and then measured the freezing point of each solution. So this is the experiment that was being done, and then the results were recorded in two tables, tables 7.1 and 7.2. If we move on, we are given table 7.1, 7.2. So is it necessary for you to digest the table now? Answer is no. Alright, there's no need for you to scrutinize the table now and try to look for trends or understand what is going on. Just know that the results of the experiments are found inside the table. So if there's any question related to mass on the freezing point, then we'll come back and revisit this table. Okay. So next, if we look at the subsequent paragraphs, it tells you how de-icer works, the chemistry of de-icers. Okay, so some de-icers dissolve exothermically. All right, we have learned in the syllabus, exothermic means to release heat. Okay, when something releases heat to the surroundings, it can help to melt the solid ice. Okay, and then subsequently there is a very important information, the enthalpy change that happens when during dissolving is called enthalpy change of solution. Okay, so when you dissolve a substance, the energy change is called enthalpy change of solution. The next paragraph, they tell you another type of de-icers that can attract water vapor. Right, this is effective when you don't have a surface layer of water to work with. Okay, so they tell you that this kind of de-icers are called hygroscopic de-icers. Okay, and then the next part gives you another table, table 7.3, where they show all the different de-icers that are commonly used and some information about them. Similarly, when you look at this table now, is it important for you to digest the table or to scrutinize each compound and the effective temperature? Answer is no. Alright, just know that there is a table, table 7.3 gives us the common de-icers used and some information about them. So if there's a question that requires me to evaluate which de-icer is better, I'll come back to this table. Alright, so now we have walked our way through the passage. We roughly know what the passage contains and what are some important parts that we need to go back to if the question requires us to do so. Okay, one thing to take note is that, do you need to fully understand the chemistry behind the de-icers? Answer is no. Okay, so for database questions, the additional concepts are way beyond the syllabus. In fact, this question is talking about something called colligative properties, which is not even taught in the A-levels. Alright, so there's no need for you to understand the chemistry behind it, but all you need to do is to be able to make use of the information given in the passage and apply it to the questions. So now we'll see how we can use the information from the passage as well as what the related concepts in the syllabus to solve the questions. The first question, use the data to estimate the number of moles of sodium chloride that dissolve in 1 dm cube of water. So dissolving sodium chloride in 1 dm cube of water would be related to the experiment that the scientist was doing. Okay, in the experiment, what she did was to dissolve sodium chloride in 100 centimeter cube. Okay, what she did was to dissolve sodium chloride and calcium chloride in 100 centimeter cube of water and to measure the freezing point. Alright, so the data was given in table 7.1 for sodium chloride, 7.2 for calcium chloride. So since we are looking at sodium chloride, we should refer to table 7.1. And over here, if we take a look, now this is the time where you scrutinize the table and make meaning out of the table. So what the table is telling you is that when we increase the mass of sodium chloride added to water, the freezing point changes. Okay, but at a certain point in time, when you have added 40 grams of sodium chloride, you realize that the solution becomes saturated. Okay, your sodium chloride does not dissolve fully. So the number of moles of sodium chloride that can dissolve, the maximum mass of sodium chloride that can dissolve in 100 centimeter cube of water is actually 30 grams. Okay, 30 grams sodium chloride can dissolve in 100 centimeter cube of water. The question is asking you to estimate the number of moles of sodium chloride that dissolves in 1 dm cube. Okay, so now you are expected to be able to recall that 1 dm cube is actually 1000 centimeter cube. So that means that in 1000 centimeter cube, we would have 300 grams of sodium chloride present. And then the next thing is to convert this to number of moles, which is what the question is looking for. So in the topic of mole concept, we have learned that number of moles is equals to mass over molar mass. Okay, so 300 divided by the molar mass of sodium chloride, which is 23 plus 35.5, and that will give us a value of 5.13 moles. In part B, the question is asking for the similarities and differences in the results of the scientist's experiment. So once again, we are looking at the experiment, so we need to go back to the part where the results are being tabulated in table 7.1 and 7.2. So to get the similarities and differences, we need to then compare the two tables and try to spot the similarities and differences. Okay, so now the very common mistake that students make when answering such questions is this. When we ask for similarities and differences, we want to look for trends, similarities and differences in trends rather than simply stating data. Okay, so for example, a student can say that when 10 grams of sodium chloride is added, okay, the freezing point becomes -8. When 10 grams of calcium chloride is added, the freezing point is -9. Okay, I know it's a difference, but what you are doing here is simply just stating the data. Okay, so what they want is a difference in the trend or difference in a certain, something that's less specific. So for example, we can say things like when at the beginning, when small amounts of sodium chloride and calcium chloride is added, the freezing point of water decreases. Okay, that is a similarity. When a small amount of sodium chloride and calcium chloride is added to water, the freezing point of water decreases. Okay, the second similarity will be this. Okay, when more sodium chloride is added and when more calcium chloride is added, the freezing point actually increases. Okay, so it will decrease to a minimum, okay, in this case, right, before it increases again. Okay, so that's the second similarity. Now we look at the differences. What are some of the differences between the two? The first difference would be this, that the minimum freezing point that sodium chloride that can be achieved with sodium chloride is -20, while the minimum freezing point that can be achieved with calcium chloride is -45. So calcium chloride is able to produce a lower melting point, a greater melting point decrease compared to sodium chloride. That's one difference. Second difference is when 40 grams of calcium chloride is added, the temperature, the freezing point of water increases to +12, whereas for sodium chloride, it doesn't dissolve fully. Or you can say something like, when more than 30 grams of sodium chloride is added, it no longer dissolves fully, while calcium chloride can continue to dissolve fully to produce a change in the freezing point. Alright, there are multiple correct answers that you can state, as long as it is not simply stating the data. Alright, you need to compare and draw certain commonalities and differences. For part C, let's look at the question. Some of the de-icers are more effective at much lower temperatures than others. Okay, so there are two parts to the question. One is to identify two factors. Okay, identify two factors, and secondly is to explain your answer. So there are two parts to this question. Identify the factors and explain how they make it more effective. So since the question focuses on the different de-icers, so we need to now shift our focus to the last part, which talks about the different de-icers, and there was a table that gave you some information of the de-icers. So the question is telling you that some of them are more effective at lower temperatures. So we need to focus on if you look at the table, there's a column which has lowest effective temperature. So we want to focus on those that are effective at very low temperatures. So that would be these two, calcium chloride and magnesium chloride. So now we compare the rest of the properties of these two de-icers compared to the rest. Okay, can you all see that the enthalpy change of solution is negative, and they are both hygroscopic. That means they can draw moisture from the air. So the two factors that you need to identify is, one, the de-icers that are more effective, they dissolve exothermically in water. Okay, so the dissolving of the substance in water is exothermic. Secondly, they are hygroscopic. So these are the two factors. The second part requires us to explain it. So why is it that de-icers that dissolve exothermically are more effective. Why is it that hygroscopic de-icers are more effective? For that, if you can recall, there was some description in the passage that talks about that. So we need to go back to the paragraph and analyze that paragraph. Okay, so this is the paragraph on the chemistry of de-icers. If we look at it, they were telling you that if the de-icer dissolve exothermically, alright, it will release heat to melt the solid ice under the layer of water and allows the de-icer to work deeper in the ice. Okay, so this is to explain firstly why de-icers that dissolve exothermically, they are more effective because they release heat to melt the solid ice under the layer of water and allows the de-icer to work deeper in the ice. Okay, second, so there's something about hygroscopic. So over here, right? So what is the chemistry behind it? So the de-icers attract water vapor from the air. All right, only then can they dissolve and produce heat. So at very cold temperatures, there's very little liquid water. So if there's very little liquid water, the de-icer cannot dissolve in it. There's nothing for the de-icer to dissolve in, and therefore it cannot work its magic. Alright, so but what is so special about calcium chloride and magnesium chloride is that they can pull water from the air and then after that dissolve in it and then releases it releases the heat required to melt the ice. Okay, so this is the second explanation. In D part 1, now we are required to draw the energy level diagrams, okay, to show the products and the energy change, okay, of solution when urea and calcium chloride dissolve in water. Right? So energy level diagram is related to the chapter on energy changes. In the topic of energy changes, we learn to draw two kinds of diagram. One is energy level diagram, the other one is energy profile diagram. Okay, so what exactly do we have to draw? Since the question states that you only need to show the product and energy change, right? We need to just show the energy level diagram. So there's no need for you to show the activation energy or the activation harm in the energy profile diagram. Right. The next thing that we need to find out though is in the drawing of the energy level diagram is whether the reaction is endothermic or exothermic. Okay. So with that, we need to go back to the table that has the information of the different de-icers, and we need to check the enthalpy change of solution. So if we go back to the table, we will find that the enthalpy change of solution for urea is actually plus 15 kilojoules per mole. Okay, and the enthalpy change of solution for calcium chloride is minus 82.9 kilojoules per mole. With the information of the enthalpy change, we can now draw the energy level diagram. So since for urea, it is an endothermic reaction, remember the reactants will take in energy. So the products will now be of a higher energy level than your reactants. Okay, so that okay, and if you can recall, enthalpy change of solution is the energy change when a substance dissolves in water. So what is the product over here? There's no chemical reaction. This is just a physical process. of dissolving a solid. So when we dissolve a solid, the substance is not changed, just that the state is changed from solid to aqueous. Okay, the same applies for calcium chloride. Calcium chloride, now when it dissolves in water, it releases energy. It's exothermic. So when the reactants release energy, the products would be of a lower energy compared to the reactants. So calcium chloride aqueous, and the energy change is equivalent to your enthalpy change of solution. Alright, a minor thing to take note is this, that especially with the energy level diagrams being put side by side, I don't know whether this is a marking point, but do take note of the relative height or the relative length of your enthalpy changes. Okay, over here for urea, since it only increases by 15, whereas for calcium chloride it decreases by about 83, do take note to draw a longer arrow for calcium chloride as compared to urea. For part 2, we are asked to suggest one benefit of using urea rather than calcium chloride. So again, we are looking at the types of de-icers, and we need to look at the table. Once again, urea is here, and then this is calcium chloride. So we need to look for benefit of using urea. All right. So I think if we look through the columns, it becomes very obvious that urea has very low toxicity, whereas calcium chloride is harmful to plants. So the benefit is that urea is non-toxic to plants, whereas calcium chloride is toxic. Part E, some of the de-icers are harmful to plants, okay, because they contain a high concentration of a particular ion. Okay, so once again, we are looking at the different de-icers. We'll analyze the table, and then since the question is talking about de-icers that are harmful to plants, let us look at those compounds that are harmful to plants. So sodium chloride, calcium chloride, magnesium chloride, and potassium chloride. Okay, and the question tells you that it's due to the presence of a particular ion. So if we look at the 4 compounds, the ion that is common to all of them is the chloride ion. Okay, so the identity is your chloride ion. Why? Because all 4 compounds are harmful to plants. They contain the chloride ion.